Welcome back to the deep dive. So we received a stack of sources this week that are less about firewalls and a lot more about financial ruin.
That's a good way to put it.
It looks like they were compiled by a CIO who woke up to an invoice that just, well, completely broke their annual operating budget.
And that's not an exaggeration, unfortunately. That is the reality for some.
So our mission today is pretty laser focused. We are diving deep into the Azure ecosystem to understand why, in the world of modern cloud computing, security isn't just about protecting your data anymore.
True, not at all. It's about protecting your financial ledger.
Exactly.
That core thesis is the absolute truth of cloud governance today. I mean, the biggest, most immediate threat to an organization using Azure. It might not be a traditional breach or data theft.
It's the budget.
It's the outright emptying of the corporate operating budget, the very feature that sold us all on the cloud. Its limitless immediate elasticity has, created an architectural vulnerability.
A vulnerability that's susceptible to what our sources are calling economic exploitation.
That's the term.
So we're moving past the classic idea of a distributed denial of service, a DDoS attack, right? Where the attacker's goal is just to overwhelm your server until it crashes.
Right, to achieve system unavailability.
We're talking about something far more insidious, something that weaponizes your own success. The denial of wallet or DDoW attack.
Exactly. And the sources make it crystal clear that while, data theft is a long-term liability, DDoW is an immediate financial shockwave.
Which means we have to look at these top Azure security tools a little differently.
We have to look at them through a financial lens, focusing on the discipline of FinOps and, frankly, the terrifying reality of uncapped financial liability.
Okay, let's unpack this. We really need to understand the mechanism of this denial of wallet threat before we can even start to discuss how to build financial guardrails against it.
Right. So denial of wallet is a specialized, you could say, cloud-native form of denial of service. To really get it, let's just quickly go back to the traditional DDoS. A traditional DDoS, it targets availability. It's trying to exhaust your CPU, your memory, or your network bandwidth until the system just stops responding.
The attacker's goal is to crash. Simple as that.
Simple as that. But the DAO attacker doesn't want the system to crash.
No, they want it to run perfectly, just perfectly expensively.
Precisely. The DAO attack is an economic denial of service. It exploits the fundamental pay-per-use billing model of the cloud.
So it doesn't need to breach your firewall or steal credentials or leak any customer data.
None of that. It just needs to force the victim organization to consume massive, expensive, paid cloud resources until the system becomes financially unsustainable. The system, as you said, works perfectly, but the bill destroys the budget.
That inversion is, it's truly fascinating, and it highlights how the core design philosophy of the cloud, that infinite scale, can be turned right back against the user. So what's the mechanism of financial ruin here? How does an attacker maximize the cost velocity?
The mechanism relies on targeting the parts of your application that are designed for elasticity. So attackers send repeated, often very small or low-cost requests that target auto-scaling systems.
Like what? What are we talking about specifically?
This includes serverless functions like Azure Functions or containerized workloads on Azure Kubernetes Service AKS, or even, high-throughput PaaS databases like Azure Cosmos DB.
And because these systems are engineered to handle spikes in demand instantly, they don't ask for permission. They just spin up more resources.
Correct. The cloud provider, in this case Azure, detects this surge in what it perceives as legitimate demand. And, it has to adhere to its service level agreement for performance. So it automatically scales up resources to meet that load.
So your system stays highly available. The performance metrics look great.
But the victim is rapidly incurring staggering, completely uncapped costs. The attacker might be paying pennies for their attack infrastructure, while you, the victim, are paying tens of thousands of dollars per hour.
That's where the human element, the fear, really hits home. Because for a DevOps team, auto-scaling is your superpower, right? It guarantees performance.
It does.
But in the hands of an attacker, like you said, it's financial weaponization. What's so fascinating here is how the core feature of the cloud, that elasticity, becomes the very weapon used against you.
And this is where the shocking real-world cases become really mandatory reading. The sources detailed an anecdote, which is now almost legendary in FinOps circles, about a DDoS attack hitting a cluster where the auto-scaling feature had no hard ceiling, no explicit financial governor.
The $120,000 mistake?
Yes. That specific incident involved the system spinning up an astonishing 2,805.24 AX large instances.
Okay, so let's unpack that specific instance type because I think the technical choice is tied directly to the speed of the financial disaster. What is an ML 5.24x large?
It's a beast. It's a memory and CPU optimized instance, often used for massive databases or critical high-performance back-end applications. Very powerful, very expensive.
And what's the typical hourly cost for just one of those if it's being fully utilized?
Well, depending on the region and the specific cloud provider, you might be looking at around $4, maybe $5 per hour for just one of those instances.
So if the system spins up 2,000 of them
You are immediately hemorrhaging between $8,000 and $10,000 per hour.
per hour.
And they ran for 72 hours, which resulted in that staggering $120,000 bill.
$120,000 in 3 days. I mean, that's not a security vulnerability at that point. That is a financial emergency that could literally shut down a small to mid-sized business.
For sure.
The key lesson there, as the sources really highlight, is that auto-scaling without proper guardrails is quite literally a blank check.
It is the embodiment of uncapped liability. But the DAO attack surface isn't just limited to scaling up expensive compute instances. The sources highlighted a truly insidious vector that targets the most basic building block of cloud computing:
Which is?
cloud storage and API metering.
You're talking about the attacks that target things like Azure storage accounts and somehow get you to pay even for failures.
Precisely. And this is one of the most difficult concepts for traditional security professionals to really grasp. In Azure storage and similar services like AWS S3, you are billed for every single operation, every put, keep, get, list, and delete request.
Okay.
Researchers discovered that even unauthorized API call requests that result in a 401 unauthorized or a 403 forbidden error still incur measurable charges.
Wait, hold on. Why would I pay for a request that my server immediately rejected because the caller didn't have access? That makes no sense.
It does when you think about the processing chain, because the cloud system still has to consume resources just to process that request header, validate the path, and run the authentication check against identity services before it can officially return the error code.
Oh.
That processing time, however minuscule it is metered and charged. So the request fails, but only after the initial billing cycle has already begun.
Wow. That means an attacker doesn't need to steal data or even gain entry. They just need to know the name of a public or even an internal bucket or endpoint and just flood it with junk requests.
Exactly. It's the sheer volume of attempted operations that bankrupts you.
And this isn't just theoretical, is it?
No, not at all. The sources cite a well-documented case where a developer received a $1,300 bill after a cloud storage bucket was hit by nearly 100 million requests in a single day.
100 million.
And crucially, the outcome was zero data theft, not even a single successful access. The cost was derived purely from the volume of attempted operations that triggered that metering cycle.
That shifts the paradigm entirely. Unauthorized access is no longer just a technical or, a compliance risk. It is an immediate, tangible financial risk.
Right.
And the severity of these financial consequences has just fundamentally shifted executive priority across the industry, hasn't it?
It's been a tectonic shift. We saw data indicating that managing cloud spend, which is really just the avoidance of the DAO threat and optimizing resource use, has definitively surpassed traditional security concerns as the #1 cloud challenge since 2022.
Let's underline that statistic because that is a critical inflection point. Industry reports are consistently showing that 82% of organizations now cite cost management as their top cloud challenge.
Right.
And that has edged out the 77% who are concerned primarily with security. That's staggering.
Yeah.
It says that for most companies, the immediate threat to their survival is internal budget collapse, not external data exfiltration.
And that urgency proves why this convergence of security and financial accountability, the discipline of FinOps, is simply non-negotiable for anyone using the cloud.
If the threat is financial?
The solution must be financial, and that leads us directly to the required operational foundation: FinOps.
FinOps, it sounds like something finance people invented purely to make engineering teams sad and to slow down innovation.
I've heard that one before.
But if it's the key defense against the denial of wallet, we need to understand exactly what it is and how it's operationalized within the Azure context.
Right. So FinOps, or Cloud Financial Operations, is essentially the operating model that institutionalizes financial discipline across the entire cloud lifecycle. It's really a cultural practice that requires cross-functional collaboration.
So it helps organizations get the visibility they need, optimize spending.
And most importantly, instill financial accountability across IT, finance, and product teams. They all have to be in the same room.
So it's not just about cutting costs then. It's about making sure every dollar spent delivers demonstrable business value and, critically, that you can predict that cost. Where does this discipline usually live inside a large organization?
Usually this is championed and centralized within the Cloud Center of Excellence, or CCOE.
The CCOE.
Exactly. The
Yeah.
CCOE is tasked with embedding these FinOps practices, and in larger organizations, they often house a dedicated FinOps function that provides that governance layer.
And the success is measurable, right?
Oh, very. The sources cite that successful CCOEs achieve some significant outcomes, including 20 to 40% cost reductions, just by eliminating waste and optimizing contracts, and a 30% faster time to market.
Okay, that last point is crucial because it directly refutes the idea that financial discipline slows innovation. It suggests that financial efficiency actually enables faster, more predictable deployment.
It absolutely does. When teams aren't paralyzed by the fear of uncapped spending, they can actually move faster. But to achieve that, you need the right capabilities. Let's look at the 3 core pillars of FinOps, starting with visibility and allocation.
Here's where it gets really interesting. How do they actually track the money in such a fluid, dynamic environment?
It starts with meticulous, non-negotiable organization, the implementation of mandatory tagging standards,
Tags.
simple metadata labels, think environment prod, dev, test, application like payment processor, and cost center. These tags are the absolute backbone of FinOps
Why are tags so foundational? What do they unlock?
because they enable precise showback and chargeback.
Okay, define those for us.
Showback is all about transparency. It gives development teams clear, easily digestible reports showing exactly what their resources cost. It's informational, and it's designed to drive behavioral change just through awareness.
And chargeback.
Chargeback, on the other hand, is the actual billing mechanism. It assigns the cost of that cloud resource directly to the business unit's internal ledger.
I can see showback working well. I mean, nobody likes to waste resources when the cost is right there in front of them. But isn't chargeback just a way to make the IT department look like a corporate cost center? Couldn't it breed resentment and make teams resistant to innovation?
That's a common and a very valid critique that FinOps teams have to actively manage. If you implement it poorly, chargeback can absolutely be seen as a tax.
Right.
But if you implement it correctly, especially coming from the CCOE, it transforms the relationship. It changes the conversation from IT is too expensive to this application costs us X dollars per customer to operate. Is that valuable?
I see. It moves teams from just operating a resource to owning its full total cost of ownership.
Exactly. If a resource isn't tagged, its cost can't be attributed, which makes optimization impossible and accountability non-existent. And that leaves the door wide open for DAO attacks to run wild with no one noticing until the big invoice arrives.
So mandatory tagging is the organizational prerequisite. What about the immediate defense mechanisms that prevent that $120,000 shock?
Okay, that moves us to the second pillar, budgeting and anomaly detection. CCOE teams establish financial budgets, often at the subscription or resource group level in Azure, and they implement sophisticated alerts for budget thresholds.
So not just when they hit 100% of the budget.
No, that's too late. Maybe at 50% or 75% of the allocated spend.
How sophisticated are the detection tools in Azure? Are we just talking about simple hard limits?
No, it's far more advanced than that now. While hard limits are of course essential, tools like Azure Cost Management and Azure Advisor offer dashboards that are established to detect, identify, and act upon unexpected increases in cloud spend, cost anomalies.
And this involves machine learning, I assume?
Yeah. It does. It's a baseline modeling. The system learns the normal daily spend profile of a workload. If that workload suddenly jumps 300% in an hour, say, due to a massive auto-scale event, the system flags it as an anomaly, even if it hasn't hit the absolute budget limit yet.
That proactive monitoring is key, isn't it? Because it catches the fast-moving DAO attack in minutes, rather than waiting until the end of the billing cycle or until a hard budget ceiling is breached. The speed of detection is the speed of financial salvation.
Absolutely. And that brings us to the third major pillar, which is cost optimization. This is the long game.
Optimization seems like the natural evolution. Once you have the visibility from tagging and the real-time detection from anomaly alerts, you can start being proactive.
This is where the CCOE leads the effort to proactively identify and even automate waste reduction. And the numbers here are compelling. We keep seeing statistics showing that an estimated 27% of enterprise cloud spend is wasted on average.
27%. That's not stolen, it's just inefficiently purchased or deployed.
That's
Where does that 27% actually hide? Is it just people forgetting to shut off a VM?
It's a combination of sins, really. It's right sizing, making sure you use the smallest possible instance type that meets performance needs, not just grabbing the largest VM available. It's identifying and removing idle or underutilized resources, unattached storage volumes, old snapshots, or dev and test environments that are running 24/7 for no reason.
And I imagine strategically leveraging purchasing commitments.
That's a huge one. Purchasing commitments like reserved instances and savings plans, that's a huge tactical choice.
Explain that.
It is. Reserving an instance for 1 or 3 years provides massive discounts, sometimes up to 72% off the pay-as-you-go rates, but it requires financial forecasting and commitment. A FinOps team has to calculate the baseline stability of a workload, the minimum compute, SQL, or storage required 24/7, and commit to that baseline.
And then you optimize for the peaks, the spiky demand, using the more expensive pay-as-you-go model.
Exactly. That commitment analysis is a core function that delivers massive predictable savings.
You mentioned earlier that FinOps is also a cultural transformation. It's not just a set of tools. It's about getting engineers who historically worried about latency and uptime to now worry about the price tag of an API call.
That cultural aspect is absolutely essential to scaling cloud efficiency and resisting that DAO mindset. FinOps aims to create a culture of cost accountability, where cost is treated as a key non-functional requirement, right alongside performance and security.
And you reinforce this through business-aligned KPIs.
Yes, through specific key performance indicators like cost per customer or cost per transaction.
So the goal isn't just to cut the bill. It's to demonstrate that the bill is justified and efficient relative to the business outcome.
Precisely. And this is achieved through hands-on education, like those regular cloud cost clinics where product teams review their usage dashboards, identify anomalies together, and learn optimization techniques from the CCOE.
This must be catching on.
We've seen a rapid institutionalization of this. Sources are indicating that 59% of organizations now have a dedicated FinOps team. That growth validates the shift in priority. You simply cannot manage cloud risk without managing cloud cost.
Okay, so we've established that the ultimate financial risk comes from volatility, that unexpected, uncapped spike caused by a DAO attack. Now, let's connect the dots and look at specific Azure security tools through this lens of FinOps. How does spending money on security services actually act as a financial hedge?
This is the critical convergence point. We have to reiterate the key finding here. Security services are not merely defensive overhead that adds to your TCO. They function as financial hedges against uncapped liability.
They provide budget predictability against the extreme volatility that DAO attacks exploit.
Exactly. The cost of safety is the premium you pay for financial certainty.
Okay, let's start with the most obvious defense, the direct countermeasure to DDoS and DAO attacks, Azure DDoS protection. What is the financial promise of the paid tier, and why is that worth the investment?
So Azure offers 2 essential tiers. There's the DDoS Protection Basic tier, which is free. It's automatically included and provides baseline infrastructure level protection.
But for anyone serious about this,
For organizations protecting high-value, public-facing applications that are potential DAO targets, you need DDoS network protection. That's the advanced paid enterprise-grade service.
and that paid tier, which our sources suggest, costs around, what, $2,944 a month for a set of 100 public IPs? It provides far more than just better filtering and scrubbing. What are the 2 crucial financial benefits?
First, that roughly $3,000 monthly cost is a fixed, predictable expense. For a FinOps team, eliminating the possibility of a $120,000 shockwave for a fixed known cost is invaluable. It's budgeted risk mitigation.
And the second benefit?
Second, and this is the absolute game changer for FinOps, it offers the crucial cost guarantee.
Let's focus on that cost guarantee. It sounds like insurance provided by the cloud vendor against their own scaling features.
It is exactly that. If an organization incurs scale-out costs during a documented DDoS attack, and that means Microsoft identifies and confirms the attack, Azure provides service credits that cover those costs.
So this isn't just hypothetical. This covers what, specifically?
It covers scale-out costs for firewalls, the spinning up of virtual machine scale set, or VMSS instances, and the consumption of backend PaaS resources. Think Azure SQL, Cosmos DB, and app services.
So wait, just to be clear, if I have that paid service and a malicious actor triggers my auto-scaling to launch 2,000 costly instances, The $2,900 premium means Azure essentially covers the $120,000 bill.
That is the contractual agreement. The service shifts the potentially limitless financial burden of scaling back to Microsoft during an active, documented attack.
Wow.
For FinOps, that $3,000 monthly cost is the perfect example of a predictable expense that eliminates the risk of an unpredictable, massive expense. The ROI calculation isn't about preventing downtime anymore.
It's about preventing bankruptcy.
Pretty much.
That truly changes the entire ROI model. And we should note, the sources suggest a tiered recommendation. If you need to protect fewer than 15 public IP resources, the IP protection tier is often more cost-effective.
Right. It offers similar core features, including that cost protection, but on a pay-per-IP model, making it scalable for smaller deployments.
Okay, so moving from the edge to the network core, let's look at Azure Firewall. This is another area where security choices are fundamentally FinOps calculations.
For sure. Azure Firewall is a managed, auto-scaling network security service. It provides advanced Layer 3 to Layer 7 filtering, and it's necessary for securing public-facing apps in a VNet. It comes in basic, standard, and premium SKUs.
The technical differences are well known, basic for small needs, premium for things like IDPS and TLS inspection. But how does a FinOps team approach the choice between these SKUs?
The choice has to be a strategic cost selection based on traffic volume. The cost structure involves the fixed base deployment rate, an hourly charge for the appliance, and the crucial variable data processing fee.
And that data processing fee is what can kill your budget if you make the wrong SKU choice.
It absolutely will.
Can you elaborate on the financial physics of that fee structure?
Look at the numbers provided in the sources. The basic SKU charges a much higher data processing fee, sitting at about 6.5 cents per gigabyte processed.
Okay.
In stark contrast, the standard and premium SKUs charge a significantly lower rate of about 1.6 cents per gigabyte processed.
So if I'm a startup with minimal traffic, the lower hourly base rate of the basic SKU looks great. But the moment my traffic volume, my success crosses a certain threshold, I am financially punished by that high data processing rate.
That is the impossible trade-off the FinOps team has to model. They have to calculate the break-even point. If a low-traffic application averages, say, 10 terabytes of data processing per month, the difference in data processing costs between basic and standard is roughly $650 versus $160. So if the higher hourly rate of the standard SKU is less than $490 more per month than the basic SKU, then the standard SKU is the financially rational choice, even if the application doesn't strictly need the technical features of the higher tier yet.
It becomes a financial hedge against your own success.
Exactly. So technical SKU selection is a core financial decision based on forecasted traffic, not just feature requirements. That's a key FinOps mandate.
And the sources also pointed out a seamless integration benefit related to WAF, the Web Application Firewall.
Yes, another calculated financial incentive. If you deploy Azure Application Gateway with a WAF, and that deployment is contained within a VNet protected by DDoS network protection.
The paid tier.
The paid tier, yes.
Yeah.
Then the customer actually pays the lower non-WAF rate for Application Gateway. It's a discount structure tied directly to the purchase of the broader financial hedge, that DDoS network protection service.
Now let's pivot to the bleeding edge of the DAO threat, the world of generative AI. We're moving from gigabytes and VM hours to an entirely new billing unit tokens. How does the denial of wallet manifest in the age of Azure OpenAI?
The new threat is what they're calling token exhaustion. Since services like Azure OpenAI bill based on the tokens consumed, both the input tokens in the prompt and, critically, the output tokens in the response, a malicious prompt injection can be engineered specifically to force the model to generate extremely long, verbose, or complex responses.
Well, it's like a malicious user keeps asking the AI to write a 10,000-word essay every time they submit a query, and we're billed by the word count.
Precisely. And the cost velocity of tokens, especially for the high-end models like GPT-4, can be extremely fast. If an attacker can automate 100 requests per minute, each one designed to maximize token generation, the cost can skyrocket almost instantly.
So how does Azure guard the wallet against this new economic attack vector, the tokenomics?
Azure OpenAI manages resource allocation via a very sophisticated quota system. It's defined by tokens per minute, or TPM, and requests per minute, RPM, quotas that are assigned to each model deployment.
And the TPM assignment is the financial capping mechanism. It defines the maximum volume of processing capability you're willing to expose.
That's it.
But how does that actually stop the billing shock in real time? I mean, considering the AI response can be generated over several seconds.
This is the genius of the financial circuit breaker. When a request is received, Azure performs a quick calculation to determine the estimated max process token count.
An estimate.
An estimate. It factors in the size of the user's prompt, the value of the max tokens parameter the developer set, and other parameters. If this estimate, the potential cost of the request, exceeds the assigned TPM limit for that minute, the system immediately returns a 429 too many requests error.
That is absolutely crucial. It
Yeah.
stops the request before the model starts processing and generating the expensive output. So the throttle isn't based on how many tokens you actually processed in the last 60 seconds, but on the potential financial liability of the request you just submitted.
Exactly. And this highlights a critical FinOps and DevOps best practice. Developers must set that max tokens parameter to the absolute minimum value required for the scenario.
Why is that so important?
Because over-provisioning max tokens doesn't just enable malicious actors to run up the bill, it also prematurely triggers that 429 throttling for your legitimate users. Their estimated capacity is too high, even if they never intended to use it all. Developers have to establish a tight financial blast radius with their code settings.
Okay, we've established the threat denial of wallet and the technical financial hedges like the DDoS cost guarantee, calculated SKU selection, and TPM quotas. Now we need to discuss how organizations operationalize this convergence. It has to move from setting up individual services to a unified governance across hundreds of workloads.
The central goal of governance is moving from reactive firefighting, paying the bills and reacting to anomalies, to proactive management, where security is just a calculated, budgeted component of a workload's total cost of ownership.
And as we discussed, the unifying mechanism for this collaboration between security and finance is the rigorous, mandatory use of Azure billing tags.
Yes, the tags are the metadata.
So then Azure policy must be the engine that enforces the rules built on that metadata.
Absolutely. Azure Policy is the enforcement engine that ensures integrated FinOps and security standards are met across the organization. It's a perfect dual-purpose tool because both security and finance are interested in consistency and standardization.
Give us some examples of these dual-purpose policies that FinOps teams rely on.
Well, the foundational policies mandate cost attribution tagging across all subscriptions and resource groups. That ensures nothing gets deployed without being assigned an owner and a cost center.
And on the cost control side?
On the cost control side, policies can be used to prevent the deployment of high-cost SKUs like those premium firewalls, or the massive memory-optimized VMs in non-production environments where that cost is just not justified.
But doesn't this cause friction with developers? I mean, if I deny them the ability to deploy the resource they need, I'm slowing down their velocity, which defeats that CCOE goal of a 30% faster time to market.
That is the core governance challenge, balancing the guardrails with velocity. FinOps teams have to choose very carefully between the effect of a policy. You can use an audit effect, which just flags non-compliant resources and sends an alert.
A soft nudge.
A soft nudge.
Oh.
Or you can use a deny effect, which hard blocks the deployment. Over-applying the deny effect leads to policy sprawl and a lot of developer frustration.
So what's the best practice?
Best practice often dictates using audit in non-production, and only using deny for financially or security-critical requirements in production environments, forcing the developer to justify the cost exception.
That makes the process an educational one rather than a punitive one. Speaking of integrating finance and security, the sources highlight how Microsoft Defender for Cloud has evolved into a cost attribution tool itself.
That's the chargeback feature within Microsoft Defender for Cloud. It's a key FinOps integration. Security plans, like the Comprehensive Defender for Servers plan, are not cheap.
Right.
Before this feature, those costs were often just dumped into an unallocated security overhead bucket. Now, using those mandatory billing tags we talked about, Defender for Cloud allocates the security plan expenses accurately across different departments or teams.
So if my team owns 50 VMs, and they're all covered by Defender for Servers, my team's budget gets charged for the security protection premium on those 50 machines.
Exactly. And this transparency creates powerful, positive incentives. If a team sees they're paying a high security tax, potentially hundreds or thousands of dollars, for maintaining 100 idle VMs, they are financially incentivized to shut those resources down.
Which achieves two critical goals simultaneously.
Right. They reduce their cost, and they reduce their overall attack surface because those idle machines are often the most overlooked and vulnerable ones.
That's brilliant. It turns cost management into a security hygiene tool. The incentive to save money becomes the incentive to improve security posture. Let's bring this all together with the compelling real-world example provided in the sources, the U.S. Office of Personnel Management, OPM.
OPM is a fantastic, high-stakes case study in FinOps maturity, particularly because it operates in the complex, highly regulated government sector.
Right.
According to their deputy CIO, their Azure cloud spend grew over 2,000% since 2021.
2,000% growth. That sounds like a financial emergency that must have rattled the entire organization. How quickly were they forced to react and institutionalize FinOps?
It became an immediate necessity. That exponential growth just highlighted the uncapped financial risk inherent in cloud adoption without strict governance. They established a formal FinOps program tied to their existing Cloud Center of Excellence, their CCOE, focusing on bringing predictability to the chaos.
What were their core financial strategies in reaction to that surge, and what kind of results did they achieve?
Their implementation focused on all the core pillars we've discussed: rigid tagging standards for explicit resource monitoring, continuous cost visibility via showback reports distributed to program teams, and establishing anomaly detection dashboards.
But their most impactful strategy was leveraging purchasing commitments.
Yes, that was the big one.
And what was the measurable outcome?
They realized a significant cost avoidance and savings of 35% in a relatively short period. This was primarily achieved by effectively managing a large portfolio of reserved instances across critical, high-spend services: compute, Azure SQL Managed Instance, storage, and Azure Databricks. They meticulously analyzed their steady-state usage to maximize that RI coverage.
The granularity of that savings portfolio is key. It shows they weren't just fixing one problem. They were optimizing across the entire application stack.
Absolutely. And furthermore, they achieved annual savings greater than $500,000 just by optimizing their storage policies and commitment tiers. This highlights that seemingly small decisions, like moving data from hot to cool or archive tiers, or negotiating better long-term storage commitments, have a massive financial impact when you scale them across an enterprise.
Operating in the public sector, though, brings unique structural challenges that most commercial enterprises don't face, right?
Absolutely. OPM highlighted two critical hurdles. First, the cost challenge of compliance. Security logging is mandated under various government regulations, which requires significant storage retention for long, defined periods.
They can't just delete logs to save money.
No. So managing costs requires actively and diligently managing complex storage, retention, and archive policies while strictly maintaining compliance. It turns storage governance into a continuous high-stakes game.
And the second hurdle is the government budgeting cycle, which moves at a glacial pace compared to the real-time cloud.
That's the primary disconnect. Forecasting is notoriously difficult because government budgets are often set 2 full years ahead of application migration schedules. They have to budget for cloud usage when they don't even know which applications will be running yet or what the exact usage profile will be.
So they have to build in massive contingency buffers, which then probably appear as wasteful spending until the application finally lands.
Exactly.
It sounds like the human and cultural element was just as important as the technical execution to overcome those structural challenges.
It was essential. OPM stressed that the success required significant organizational change management. Senior management buy-in was non-negotiable. It ensured that FinOps was taken seriously across the board, and they had to foster those cross-functional relationships. FinOps truly is a team sport involving IT, finance, procurement, and the application owners.
And how did they sustain that behavioral change?
Through continuous training and transparency, they ran those regular cloud cost clinics where application owners and engineers reviewed their dashboards and were publicly accountable for their spending. It created an environment of positive peer pressure toward efficiency.
And I believe they integrated financial decisions into their change management processes.
Yes, things like activating new security plans for Microsoft Defender. That was moved into their formal enterprise change management process to ensure a financial impact analysis was always done before activation.
This journey has been incredibly illuminating. We started with the terrifying reality of the denial of wallet attack, where the cloud's inherent elasticity turns into financial ruin. And we've established that the most effective defense is not solely technical, but financial, institutionalized through the discipline of FinOps. So, what does this all mean for the organization listening?
It means the conversation around cloud safety has fundamentally changed. The cost of safety is the premium you pay for budget predictability. The most resilient organizations, they treat security not as a separate, unavoidable cost center, but as a critical, auditable investment that guarantees financial sustainability in a pay-per-use world.
And they use those paid services like DDoS Network Protections Cost Guarantee and Azure OpenAI's TPM quotas as calculated financial hedges against that extreme volatility.
Exactly.
So the ultimate win is accountability, enforced through clear Azure policies, mandatory tagging that eliminates unallocated dark cost, and chargeback mechanisms that align financial responsibility directly with the technical ownership of the resource.
That's exactly right. But the frontier of cloud governance is still moving. OPM, for instance, noted that their next steps include developing baselines for forecasting the complex and volatile costs of artificial intelligence and improving their allocation models for shared costs, like core networking and security services.
That last point, the constant innovation in both technology and billing constructs, that's the final challenge, isn't it? The rules of cloud finance are constantly being rewritten by the providers.
Indeed. If an organization fails to keep pace with these new billing constructs, whether it's tokenomics, new storage transaction tiers, or emerging serverless consumption models, they risk being financially exploited by external actors or, frankly, just bankrupted by their own infrastructure through inefficiency.
So the convergence of FinOps and security isn't optional.
It's a fundamental requirement for financial survival in the cloud ecosystem. The challenge going forward is ensuring that the most important firewall in the cloud protects the organization's wallet.
A compelling and financially sobering challenge to end on. Thank you for this deep dive into the financial physics of cloud security.
My pleasure.
Until next time, stay curious and make sure those guardrails are protecting your wallet.